Let us discuss about some atomic models. So you know that after the discovery of the protons and electrons, scientists they are entered into a new field because they wanted to establish what is the position of these subatomic particles in the atom. You know that atom is made up of the three subatomic particles, that is called proton, electron, neutron. But when they entered into the new field, so they want to establish what is the position of these subatomic particles in the atom. So in that, in the 1920, I mean in the 20th century, so that J.J.Thomson, he's come approached with his models with experiments, but later it was found to be wrong. So anyhow, he has proposed its own theory. So this theory says that you know that atom is made up of the positive charge and negative charge, that together we are going to call as a neutral. It is electrically neutral. So in that during the time, the scientists were they knew that very well about this atom is consists of the positive charge, that is called proton, and in order to maintain the balance, in order to going to balance out, the negative also will be there, negative charge, that is called electron, in order to maintain the electrostatic force of attraction, I mean in order to maintain the electrically neutral. So they believed that. So later, after his proposal, after this theory, what happens? It is become the plum pudding model. Why it is going to be called as a plum pudding model? Because of this positive medium in the atom, which is going to pudding with the electron. So after this proposal, so like this, he has going to propose his theory. So let's see the summary of this one. So first model which is going to be established by this is called J.J.Thomson model. So that was the first atomic model. So after the discovery of this atom from the Dalton's atomic theory, so scientists were entered in new field. So that one, in that first comes J.J.Thomson in the year 1928. He is going to propose this one atomic model. So what is going to tell that the atom possesses the spherical shape. So it looks like a spherical shape with a radius about the 10 raised to minus 10 meter or 10 raised to minus 8 centimeter. So carrying the positive charge. So this is the entire positive charge in the atom. The electrons are embedded to balance the electrostatic force of attraction. So in order to maintain this electrostatic force of attraction, so the negative charge will be there, that is called electron. So in order to maintain the electric neutral, you know that atoms we are going to call always it is electrically neutral, right? So in order to balance out this positive charge, electrons are also embedded in the atom. So next one, so it is going to be known as plum pudding model. Yes, I told that plum pudding model because of these positive medium in the atom, which is going to pudding with the electrons. Or it is also called as the watermelon pudding. We are also going to call it as watermelon model. So why? Because watermelon of the positive charge with the plums or seeds or electrons embedded. So just if we go through imagine the watermelon, you know this watermelon, it looks like a spherical shape. When you cut into two pieces, what happens? You look like a red color, right? So that red color you are going to assume like it is called positive. That is the entire positive charges. A red color you are going to appear, right? So that is called positive charge. What you are going to see the small black colors, that is seeds called electrons. Like this, he is going to compare with this simple watermelon shape. But later this was failed, right? But anyhow, he is going to propose in that own way. So like this, the atom is consists of the positive charges. In order to maintain this positive charge, the electrons are also embedded in this atom. But they didn't know how this positive charge come from, where it is coming from. So like this, so one by one theory which is going to be exists here in order to maintain the atomic models. Let's discuss about the second atomic model. So that is called Rutherford's atomic model, or also it is going to be called as alpha ray scattering experiment. First model we have seen, that is called J.J.Thomson atomic model, and second one is called Rutherford's atomic model. So why these model were exists? Because of the one parameter that in order to find out the exact position of the two fundamental subatomic particles or fundamental particles, that is called protons and electrons. So in that way, their only aim is to find out their positions of these protons and electrons in the atom. Rutherford had conducted an experiment that is called alpha ray experiment. So in that experiment, he is going to take the this is called an radioactive element. He has chosen the radioactive element. Why? Because the radioactive element he has taken because of the reason that they are always emit the alpha particles. They have the capacity to emit the alpha particles, and this radioactive element which will be enclosed in the lead block, that is called lead element. That is called lead element made up of this box. Is going to be enclosed in that box. So this is called radioactive element. So when they has chosen this radioactive element, so they are started to emit the alpha rays, which is called alpha particles. So which is going to pass through these slits. So this is called slit. So when these alpha particles which passes through the slits, so they come and strike against this gold foil. This is called gold foil, and most of the rays will be scattered here. So like this, they are going to be scattered. So some of them are deflected, some of them are undeflected, and some of them more deflected. So like this, after looking this screen, so those scattered lights, I mean those scattered particles are made to fall on these circular path. That is for circular screen. That is for that the screen is made up of the zinc sulfide screen. So this screen is made up of the zinc sulfide, that is for coated with this zinc sulfide screen, and they produce the flash of light. So when they fall on these scattered lights, when they fall on these circular screen, so he is going to observe like this. So he has made some observations. From this experiment, Rutherford have observed some of the points. What are those points? First point, it is going to says that when most of the particles which pass through this gold foil, so maximum number of the particles will get scattered. I mean they are going to be called as undeflected. These are called undeflected. See like this is rays when this pass through the gold foil. So these are called undeflected. See here, these are called undeflected. This is called undeflected. Like this, most of the particles he is going to observe that they are undeflected, and some of the particles, only some of the particles, they will get deflected by small angle. So like this, small angle. So these are called the small angles. Only small angles they will be called deflected, and some of the maximum number of will be undeflected. Like this, they are moving in the straight forward like this. And very few particles, they get bounced back by nearly 180 degree like this. This is a particle which strikes this is called nucleus of an atom. When they strike alpha particle, when they starts to emit, so what happens, they get bounced back around nearly 180 degree. So like this, Rutherford is observed so many things from this experiment. Based on these observations from this experiment, the Rutherford drew some conclusions. He is going to make some conclusions based on these observations, that he is going to finalize the structure of the atom. So according to him, he is going to finalize that. I mean, he is going to conclude that the most of the rays, you know that most of the alpha particles, when they hit the gold foil, what happens? They are undeflected. Most of the particles they are going to be called undeflected. It means that, I mean, when they hit the atom, most of the space in the atom is empty like this. When you see this one atom, so what happens? He is going to conclude that most of this space in the atom is empty. So that's why all the rays which were undeflected. So according to his conclusion. And second conclusion, it says that only some of the particles they were deflected by the small angles. Deflected by the small angles, and some of the smaller parts of that particles which were deflected very long angles, that is called larger angles, nearly 180 degree. So these, when you look this deflection, that is maybe smaller angles or larger angles, that is from the center of the atom. So he is going to tell that, so all the protons which are going to be centered, so all the protons which will be centered, that's why some of the rays which are going to be deflected from the center of the atom. He is going to conclude like this. And also he is going to observe that when the protons which were at the center of that atom, so he is going to call as this one as the nucleus. So you know that when an atom models, when the center is nucleus is made up of the protons. So around these protons, around these nucleus, electrons will revolve around the nucleus. So like this, he is going to conclude that this is the nucleus. So surrounding this nucleus, so many protons will be there. So that's why the deflection from the smaller angles and larger angles from the center of the atom. And also, he is going to conclude last one, that mass of that atom which is going to be concentrated at the center of the atom. He is going to consider that all this mass of this atom which is going to be concentrated at the center, that is called nucleus. So from these conclusions, we are going to conclude that. So you know that from this J.J.Thomson model, we have found that radius of the atom will be 10 raised to minus 10 meter, right? So but here what happens? Nucleus is very small as that of the atom. So when you consider this as atom, so nucleus will be there. So that's where the nucleus will be having the radius will be very small compared to this one one atom. So when the atom is having the 10 raised to minus 10 meter, means that radius of the nucleus will be 10 raised to minus 15 meter. That is what very short from that radius of that atom. So based on the observations and conclusion from the alpha ray experiment, Rutherford is going to propose its own theory based on these observations and limitations. He is going to tell that the atom consists of the two parts. In the atom will be the two parts he is going to divide. So that is called central nucleus. He is going to call as the central nucleus, and second one part as the region outside the nucleus. So if I take this as the atom, in the atom this portion I am going to call as this nucleus. This portion, first part I am going to call as the nucleus, and this is the first region. Second region outside this nucleus is going to call as the second part. So first part is central nucleus and second part is outside this nucleus. So this is the first one, and second one, nucleus is very heavy. You know that nucleus is always heavy that of that atom, because it consists of the protons. It consists of the protons and neutrons, right? So third one, whole mass of that atom is concentrated on the nucleus. That whole mass of that atom, which is going to be concentrated on this one center of that nucleus. So that has a capacity to hold the everything of that atom. And region outside the nucleus, that consists of the electrons. As you know that the region outside this nucleus, the electrons will be revolving, right? So these are the electrons. You know this, these are the electrons. Region outside the nucleus consists of the electrons, and volume of that nucleus is very minute as compared to the volume of the atom. So I told that. So the volume of this nucleus, always the size of the atom is bigger than the size of the nucleus, because nucleus is the part of the atom, but atom is not a part of the nucleus, right? When you look at this one, this is the atom and this is the nucleus. So it will be, the size will be very small compared to this atom. So here the volume of that nucleus is very small as compared to the volume of the atom. So next point, number of protons in the nucleus. Nucleus, you know that protons will be there. So number of protons in the nucleus, which is equal to the number of electrons outside the nucleus. So if total, how many electrons will be there in the nucleus, protons and total number of electrons together is going to count here. So number of protons equal to number of electrons. So that then only you are going to call as, that is, atom is electrically neutral when you are going to say, when they containing the equal number of protons and equal number of electrons. The last point, the electrons revolving around the nucleus in closed orbits, right? When you look at this one, the electrons will revolve around the nucleus in a closed orbit, and centrifugal force balances the force of the attraction by the nucleus. So nucleus, which is going to balance this force of attraction and keeps them in their path. So continuously they are moving in the circular path. So and this Rutherford's experiment is going to resemble that the solar system of the planet. Yes. If you consider this, that the role of the sun, which is going to cover in the atom, is called nucleus. So which is going to carry the role of the sun, that is, which will be center, and surrounding this one, all the planets, all the planets revolve around the sun. Like this, the number of electrons which will revolve around this nucleus. So like this, so has proposed his own atomic model. So this is called Rutherford's atomic model.